All right, so you want to join the elite of keyboard builders who handwire their boards. Awesome. I applaud you because this is what I wanted to do for a while, and I only took the dive into it about a week ago and found out very quickly that although it was intimidating, it is actually not too complex. So what we're going to be doing today is we're going to be building a 3x3 macro pad. All the links to this stuff will be in the description below. All my handwired builds are down there. But the reason I chose a 3x3 macro pad is that it is just small enough and simple enough to teach you the concepts of a hand-wired board that you can then scale up to whatever you want. But before we build that, what we have to do is hop into Photoshop so I can diagram some stuff out for you, give you some theories and concepts. The first concept to understand when it comes to any board, not just a hand-wired board, is the keyboard layout matrix. And basically, it's a very simple concept. And if we look here, this is our 3x3 macro pad. This is the underside, so these are the pins here. Basically, each key is assigned a coordinate in the matrix, and that's how the controller knows which one is pressed. But if you imagine here, this is 0, 0, and it only starts top left, and then it goes horizontal across the row, and then it will go columns. So columns are vertical, horizontal rows, so it will go across, then it will go to the next one. But we'll just label these as 0, 1, 0, 2, then it goes down to the next row. So this will be 1, 0, 1, 1, 1, 2, and then this will be 2, 0, 2, 1, 2, 2. Remember in code stuff starts at 0, so 0 is technically 1, but I digress. So with that said, basically what we have here now is the keyboard layout matrix. And if we say connect this column here to pin 3, and then this row to pin 4, we'll go over this more in a second, how does it know when key at 1, 1 was pressed? Well, I mean, you can simply see that it's a cross here. So it creates a cross at 1, 1. So if this is pressed, the controller is constantly listening for changes of when a key is pressed. And then once it detects that 1, 1 was pressed, it's going to say, hey, QMK, 1, 1 was pressed, do something. Simple as that, really. It's not too complicated. But with that said, we now have to talk about limitations of the controller. So when it comes to the controller you choose, it's going to be very dependent on the board you want to build. So what do I mean by that? Well, if we just take a look here at our example 3x3 macro pad, we have 3 columns. Remember, they're vertical. So we'll label these as 1, 2, and 3. And then we have 3 rows. Remember, those are horizontal. We'll label these as 4, 5, and 6. Now, for each row in each column, it's going to require a pin on our controller. This is a Pro Micro. We have 18 available pins on this controller. So we have 6 here. We can use 6 of our 18 pins. So we'll just label these as 1, 2, and 3, 4, 5, and 6. So we're using 6 of our available 18 pins. Now, that's not an issue for this macro pad, obviously. But say you wanted to build a 60%, an 80%, or 100% board, it's very likely that you would need, say, 20 or 25 pins, where a Pro Micro just won't support that. Now, there are a few options you can do there. There's different controllers out there. I think Blue Pill is one of them. I think some bigger Arduinos. I think there's other Arduinos you can use. But I'm most familiar with a Pro Micro, so that's what we're using in this tutorial here. Or you could look into something called a GPIO extender, which would basically connect to multiple pins and then give you more pins on top of those pins. I don't know if those are available for a Pro Micro either, because I don't do that. I build tiny boards, so I don't ever run into this issue. But if you say want to build a bigger board, just something to keep in mind that you might need more pins than are available on the controller you're choosing, so you'll have to look at different options. So now you hopefully understand what a keyboard matrix is. You understand that your controller is going to be directly impacted by the board you want to build. Now let's actually talk about wiring this thing. And I'm going to start specifically with the columns because they're very simple to understand. And then later we'll talk about the rows because they're a little bit more complicated to understand. But with that said, if we just look here on our macro pad, the columns are extremely stupid simple to wire up. And basically all you do is you just link them vertically like so. Remember, this is a piece of wire or copper. You're just soldering the switch pins to it. And then all you need to do is assign each column a pin on your controller. Very, very easy to do. And it's just done just like that. You just draw it in and you're done. But with that said, we're going to now talk about the rows because they get a little bit more complicated with something called diodes. Diodes are a simple electrical component that allow current to flow only in one direction. And that's typically denoted by a black line or an arrow, cathode, anode, technical terms. But that black line basically says, hey, current's only flowing this way. And the reason they're important for a mechanical keyboard build is that it pretty much gives you what's called better end key rollover. So when you press multiple keys, it will actually register each individual key instead of giving a random mashup. But with that said, wiring them up is just as simple as the explanation of them. And what we're going to do is we're just going to take this middle row here and just wire this one up. And basically, it's the same theory as the columns, where you have to take a wire or a solid wire or an actual wire and then attach it to a pin, just like so. And then all you have to do with the actual diodes is you put the diode here, you take note of that black line, and that's denoting the current flow, and then you just wire it up to this piece of wire. So very, very simple. Just like so, and that's it. That's all you do. You do that for each row, each column, and then you're pretty much wired. With that said, hopefully at the beginning of this, you were intimidated at handwire boards, and now hopefully you're ready to actually put it into practice because you understand enough of the concepts, and that's what we're going to do. So we're going to go to the shop, and we're going to actually put this macropad together. All right, so it's now the next day, and here is the case. I got it off the printer this morning. I did use my solid infill settings on this, so it's like a solid chunk of plastic. Keep in mind, you can download this in the description below. I will link it. But with that said, what we have to do now is we have to put the switches into the plate, and then we can begin to solder it up. So what we're going to be using to wire this up is some 16 gauge copper wire, but first we need to straighten it to prepare it, and I'm going to show you how I do that with a vise and a drill. Alright, so now we have our straightened copper wire, and the reason I use copper wire instead of just regular wire is that it basically gives more strength to the keys as they're like soldered together, so it kind of, if I can get this here, it will kind of hold them together so that they don't pull out of the plate as easily. If you do have issues with your keys pulling out of the plate when you're changing like keycaps, you can hot glue them in, but it shouldn't be necessary with my design files because I made them a little bit tighter than normal. But with that said, now all we have to do is do the columns, and then I'll talk more about the diodes after we do the columns. So we're going to start with the columns, which you can see are all lined up like that. We're using the right pins on the switches, and all we have to do is just solder these to the actual wire. So a quick tip about soldering with copper wire is that you don't want to be too hot on your temperature. I'm doing 350C. Because if you go too hot, you might actually melt the housing to the switch, but if you go too cold, you won't get enough heat into the wire to actually melt the solder. So just something to keep in mind, keep it around 350, 320 to 350 should be good. But with that said, let's solder these now. Alright, so now all the columns are soldered up. The next step is the diodes, which what you first have to do is actually tin each one of the other pins. That way when you go to stick the diode on, it's very simple to do it. So I'm going to show you that process now. So one of my joints got a little bit messy right there. Which is fine. But what we're going to do now is get the diodes on, and then after that I will talk about something important, which is not shorting out on the intersections. But first we have to get the diodes all linked up, and the way I do that is pretty much just tinning them to the pins and then running them straight up. So these are the diodes we're going to be using, and remember that current flows towards the black line, so it's going to go this way, which means on our board we're going to be wiring the rows to the top here, so we want the diode facing that way. With that said, what we want to do first is clip off the opposite to the black line to about 5 millimeters or so, just to make it a little bit more manageable. This way, when we solder it on here, we don't have a massively long leg flowing into our other switches. All we have to do now is just simply take them, we hold it to the pin, just like so, and all we do is just connect it, and that's it. And we just do that for every single switch. So now that everything on here is wired all up, what we have to talk about now before we actually wire the rows is shorts. Because if you see here, when we wire up, say, this copper wire across, on those intersections between the copper wires, it has the potential to short out. So what we're going to do is we're going to actually wrap the sections of this in heat shrink tubing so that it doesn't short. So all I do for this is I just take the row wire and I place it over where it's going to connect, and you can see each diode would connect to that. And I just take a paint marker and I mark off the intersections. So we have one here, here, and then right here. So then you can see I know right where I need to put that heat shrink tubing. So after these are heat shrunk, all we have to do is take it and we just place it and align those up right on the board like so. And you're going to hold it in place while you bend the long pins of the diodes over the copper wire. And this will hold it in place. You can see that the diodes are just running over that copper wire here. And then all we're going to do is solder these to the copper wire. Then after that, all you do is you just clip off these wires flush with that copper wire, just like so. And there you have it. That's one row completely soldered up. So all you have to do now is do the same thing for each and every row. I'm not going to show that because it's just the same thing over and over. But on the top row, you can see that there won't actually be any intersections, so you don't need to do the heat shrink here. So here we are. We're all wired up now, just like so. Hopefully you can see that. And now we have to talk a little bit about the controller before we actually wire it up, because we have to do some firmware stuff first. So the first step to getting the controller prepared for the actual board is we have to program the actual firmware. So I'm not going to go over setting up QMK firmware on a local install. You can read the documentation down below. I'll link it. And it's fairly simple to do. But after that, all you're going to want to do is get into your QMK firmware folder. And we're going to run a simple command called QMK new keyboard. We're going to press enter, and then it's going to prompt you for the keyboard name. Now, we're building a hand-wired keyboard, so the convention for this is that we actually put it into Handwired, and then we name it whatever we want. So this is going to be obviously the Scotto 9, and we press enter. It's going to ask you for your GitHub info. This should be filled out by default, but I'm actually Joe Scotto. Mine's not correct, so I'll just enter that. And then your real name. I'll just put my real name. And then we're going to get this prompt, which is basically asking what the layout is. We're going to put 51 for none of the above because we don't want to have it predefine it for me, because I want to explain how it's done. So we're just going to press enter. And then this is the more important part here, which is the actual controller, the chip that you're using on your controller. We're using a Pro Micro, which is an Atmega 32U4. You can see that that's pre-selected. But depending on the controller you're using, this might be different, so keep that in mind. We're just going to press enter. And that's it. We now have a new keyboard created, and we can just simply CD into it by CD into right here, keyboards / handwired / Scotto 9. And then we can open this inside of VS Code. And here we are. We now have all our key map files here, which is pre-populated with the ortho 4x4, which we will change. We have our info JSON. And what we're going to focus on next are the matrix row and columns. So what we're looking at right now is the pinout for the Arduino Pro Micro. And basically what we have to do now is define which pins are going to connect to which rows and columns. And this is really simple to do. So what we're going to actually just do first, I'm just going to take a screenshot of this and then pin it to my screen so we have it for reference. And we're going to go back to VS Code here. And I'm going to go inside of info.json, and then we're going to look at the matrix pins property. And you can see here that I already defined the columns as D1, which will refer to 2. And I like to add a comment with the actual number of the pins on the Arduino for quicker reference when I'm building it. And then we defined D0 for pin 3 and then D4 for pin 4. And that is the columns. So all you do is basically just link these up to the pins on here, and those are the ones you use. I did the same thing for the rows. So we have C6, D7, and E6. So we have C6 as 5, D7 as 6, and E6 as 7. And that's it for the matrix pins. It's as simple as that to link them up. If you had a bigger board, of course, you'd have more pins in use. If you had a smaller board, say you had like a crazy 1x1, you just basically wouldn't have any of these here, and it'd be something like that. but the theory applies to pretty much any board you're building. You just have to link up the pins, 2 pins on the controller. Simple as that. Now let's turn our attention to the layouts property. And basically all this is defining where the keys are within the keyboard matrix. And by default, if you don't select a predetermined layout, it will actually just put layout ortho 4x4. And this is very useful for us with the macropad because it's very quick to actually modify this to our needs. So all we're going to do is we're going to just label this as 3x3 because we have 3 columns and 3 rows. And remember, everything starts at 0, so 3 is actually 4. So anything with a 3, we can actually delete. So this entire bottom row here, 3, 0, 3, 1, 3, 2, and 3, 3, that's the bottom row. We can delete that. And then anything else with a 3 is the 4th column over because we have a 3x3. So we can delete this one, and then finally delete this one, and then clean up this trailing comma. So there we go. We should have now 9 different keys in here, which you can see just like in the beginning of this video, we have 0, 0, 0, 1, 0, 2 for the top row, 1, 0, 1, 1, 1, 2, and so forth. And basically, I'm not going to dive too deeply into defining like bigger matrices because we're talking about only a 3x3 here. This is kind of where you're going to have to, depending on what you're building, figure it out on your own. Sorry, but for what we're building, this is what we need. And now we can turn our attention to the key map. Well, inside of the info.json, I also wanted to talk about 2 other important things. And the first one is this keyboard name, which is basically just what your computer is going to see the keyboard as. Obviously, it's named at Handwired Scout09, which isn't correct. So we're just going to rename this to Scout09. But the more important thing in here is this bootloader property. And basically, this determines which bootloader QMK is going to use to flash firmware and do things like that. I'm not too certain exactly what it is, but I do know that unless this is set to Katarina, which is what we're going to be using, you won't have what's called boot magic, which basically means when you press the key at 0, 0, you'll be able to enter bootloader mode. Or if you have, say, bootloader mode bound to a key on the board, this will enable you to reset the board without having to physically short the pins or use a reset button. So now here we are within the key map file, and obviously this is still using the layout ortho 4x4, whereas we just defined it as layout ortho 3x3. So the first thing you're going to change within here is to match that to what you defined as your layout, which we did 3x3. And then the other thing is that this has 12 parameters, whereas it's expecting 9. So all we have to do is delete this bottom row here, and then delete these here for the 4th column. And then we'll also delete that trailing comma, because sometimes C doesn't like that. But with that said, that's pretty much it for this file. You're free to do whatever you want now with the key map. You're probably familiar with this for like flashing boards on the QMK configurator, or you've probably done firmware on your own before too. But with that said, I like to just do on a macropad like this for testing, is I like to define everything as just like a number pad. So we'll just define these as 6, and then we'll do 5, 4 over here, 7, and then 8 and 9. And then we'll also delete this just to clean it up a little bit. And that's pretty much it for the key map. Now, the final thing we have to do is actually compile it to make sure we made no mistakes. Now, we just come over to our terminal window, and all we're going to run is a command called qmk compile, and then you're going to do -kb for keyboard, and then remember we put it in the handwired /Scout09 folder, and you're going to do -km for key map, and we are working on the default key map. We'll press enter. We'll wait a second while it compiles, and hopefully no errors happen. It looks like we're not getting any errors. This will all compile, and then if we open our QMK folder, you'll see in here, if we go back, just change this to columns, in the root of our QMK folder, we have this handwired Scout09 default hex file. That's your firmware that you're going to flash to your controller. It's the same process if you got it off the configurator. Very simple. I'll show you that now. So all we're going to do now is just open up QMK Toolbox. We're going to locate our firmware, which remember it's in the QMK firmware folder. We're going to select it. We're going to plug in our little Pro Micro, get an LED on it. And then we're going to just short out the reset and ground pins, which should put it into DFU mode right here. And now all we have to do is click flash. This will do some stuff. And then just like that, this is ready to get soldered. So the way it works is that the rows and columns always go left to right. So if we look at it this way, we can see this would be your top left key. So we go left, and then we also go down. So what we'll do is we'll go 2, 3, 4, and then 5, 6, 7. So you can see that that's 2, 3, 4, 5, 6, 7. So now you can see that we have it wired up to 2, 3, and 4. So 2, 3, 4. And now we have to do the rows, which will be 5, 6, and 7. So now there's everything wired up. Should be all good. I'll give you a chance to look at this just so you can get an idea. But now what we have to do is test it. So I like to test my boards with an iPad on keyboard tester, and before I bolt everything down, I like to just plug it in and make sure that we're getting the proper rows and everything's aligned right. No keys like backflowing. That looks good. So now we can just bolt it down and we're good to go. Here it is, the completed macropad. They came out really nice. It has like a Blackpink K-pop theme going on. But with that said, I did want to mention something here is that I actually got quite frustrated when connecting the controller. So I do apologize that I didn't really show too much of that process other than like where to connect stuff kind of. And that leads me into a point of basically you're going to run into bugs when doing something like this, when doing a hand-wired build specifically. And there's only so much that I can teach you and so much that you can learn from videos and stuff. And eventually you're going to have to debug stuff on your own. So with that said, just be prepared for that. If you're doing a build like this, that you are going to run into bugs, it's just going to happen. But hopefully I gave you enough guidance today to where you can actually go out and start building your own stuff. And with that said, I will link all my project files to all my hand-wired boards in the description below. I'll link all the stuff I used to build this in the description below. And hopefully this board will be on QMK very soon. I'm in the process of getting my changes merged into the actual QMK repo. They're all approved. I'm just waiting on someone to actually merge it. But with that said, I hope this helps someone else out today. And yeah, I'm like all fumed from solder, so I can't speak anymore. Yeah, I'm done. I'm out. I'll see you guys next time. Peace.